This is an early Ironclad lift motor, or as my friends in America would say, an elevator motor. And I find it quite confusing, I have to be honest, because I'm quite confused as why let's say an elevator would need a motor of this size being fairly small. I mean, it's not light, it weighs about 27 kilograms, but for an elevator, why would you need a motor of this size? Surely they'd be much larger, much more like that size, which is, you know, sort of about almost half a ton. So I mean, that's what you'd expect from an elevator motor. So why would an elevator use a motor of this size? I'm not quite sure. Could it be something like a dumbwaiter, one of those small lifts that are used transporting food up and down from a kitchen to a restaurant, or a motor to use to opening and closing the doors? But then, you know, a lot of the early elevators were manually operated gates on the doors, maybe with an operator doing it for the passengers. So I don't think that's a sort of an answer. Anyway, it's made by the Elevator Supply and Motor Repair Company, Elevator Supply and Repair Company, Chicago and New York. Very strange voltage, look at that. 10 volts and 6.25 amps. Very low voltage, very unusual. Yeah. So yeah, it kind of confuses me a bit. Why would they make a motor that small? I'm not sure. Maybe they started manufacturing. They started off with manufacturing elevator motors, and they started diversifying into making universal motors just for the general market. Not sure. Anyway, let's see it running and see how it ticks over. Right, so I've given it a bit of oil in the bearings here. They're a bit dry. I've only ever actually run it once before, and that's quite a long time ago. So so it feels a bit stiff on there, but hopefully that will loosen up when we get some power going through it. The bearings are actually the same design as the Otis lift motor that was in my previous video, if you saw that. It has the shaft has a very loose fitting ring hanging on it, and the ring picks up oil from a sump sort of down the bottom here. So it's sort of large scale engineering sort of reduced down to a small motor, which I suppose makes sense when they were probably building large and small motors. They just employ the same technique for everything. Anyway, let's turn it on and let's see what happens. Right, so we've only got 10 volts to play with, so we're not going to sort of wind this variac up very much. We've got DC coming out here, and right, let's have a look. Okay, it's picked up straight away, almost. About 5 volts it picked up. Very sensitive to increases in voltage. So there we are, 10 volts, 5.8 amps. No load, obviously, so if you had a load on it, it'd be higher. Yeah, seems to be running quite well. And obviously I can touch any of the electrical parts because it's only 10 volts, not going to hurt me. Okay, so it's series wound, so there's only two contacts you've got to put the wire, the connection onto, and there's linking wires, very frayed, down here that sort of are linking the armature to the field windings. So you can see that bearing going around. There it goes, but you can see it when it focuses. That's that ring going around the motor shaft there. It's actually running very well. Now the muck has burnt off the commutator. It's actually running quite happily there. like I say, I have no idea why an elevator would have a motor of this size, but I quite like it. It's a huge great lump it is. So yeah, it's an unusual thing. I have no idea why it was, what its intended purpose was. And just for a laugh, I thought I'd show you this as a comparison of size, just to show how small this is for an elevator motor.